Good afternoon, pre-cal type people. Hope you're all having an amazing day. Today we're going to be talking about properties of logarithms. It's a little lengthy, so let's get into it. You have 5 properties of logarithms that will help us to simplify logs. And there's little tips and tricks to remember a lot of these, but starting off here with number 1, b to the power of log base b to the m. This base b and this base b pretty much make the entire thing cancel down and simplify out to be just m. So that's useful to know. Log base b of b in the same manner. Log base b of b to the m is just m. This is saying again b to the m equals b to the m, which kind of just makes sense. B to the m, if you follow your little circle thing, b to the m is supposed to equal b to the m, which kind of makes sense. If you are adding two logarithms together, if you are adding two logarithms together over here, you can simplify those by saying it's the log base b of m times n and multiply them together. This is called, when you're going this way, it's called condensing. When you go from multiplying to addition, separating out your logarithms, this is called expanding. And same over here. If you are dividing these out, because you're working with exponents here, when you're dividing exponents, subtract their, whatever you call these things. Alright, then you've got log base b of m to the k. What this is saying here is that if you have a value for k, you can take and drop the exponent down to the front. So if you have the value for k, take and drop the exponent down here, that becomes k log base b of m. And this one is the one that we use quite a bit, especially in your upper levels. We use this quite a bit to simplify. And so what we're going to be doing here is going through and just kind of talking about how do we simplify, how do we expand, how do we evaluate, all that stuff. So don't worry about this part up here. Let's go down to number 1. Evaluate 5 log base 5 of 18. Well, that's one of our properties up there. So that whole thing is just 18. Log base 3 of 3 automatically tells me it's just going to be the exponent, which is x minus 2. The natural log of e, you've known for a couple of days now that the natural log and the e cancel out. That's just going to be 3t, whatever the exponent is. And that's the same thing as saying log base e of e to the 3t. And e to the natural log go away. And that's just t squared. So really easy to go through and simplify and evaluate. Now properties 3, 4, and 5 follow from the same logarithm properties we've already seen. So to expand log base 4 of 5 plus x, right, because you are multiplying their bases, you can add their exponents. I can expand this and call this log base 4 of 5 plus log base 4 of x. And I've got a cool way to remember this when you get into class tomorrow. Condensing, it goes the same way. If you're adding logarithms and the base is the same, then you can call that log of 2. And then we can take 6 times 10, which is 60, right? So log base 2 of 60. All right. The subtraction and division one. So if you're starting out dividing, this is the natural log of 6 minus the natural log of x. The condensing portion is the natural log of 50 over 25. This one is positive, this one is negative, so the negative goes on bottom, which is the natural log of 2. And then finally here, bringing it down. And this is the one that I said we use quite a bit, even a little bit more than the rest of them, and that's the log of x cubed. We can take that exponent and drop it down and call it 3 log x. Over here, condensing it, bringing the power back up, That would be log base 2 of 3 squared. Take this guy and move him up here, which is log base 2 of 3 squared is 9. So just a quick little introduction, and the next portion is what I want to spend the majority of the time on here. That's this guy. Expand as much as possible. So for 11, 12, 13, 14, we're going to expand these guys as much as possible. So it's a relatively simple process. What I like to do is start off with separating my division if I have any. So I've got log of 8x cubed, and I'm just going to leave that in parentheses, minus log of 5y squared. Now I'm leaving the square out here because it's outside of this. So to simplify a little bit, I can bring this 2 down here. I'll call that log 8x cubed minus 2 log 5y. Excuse me. So I can break up these since I'm multiplying here. This is going to be log of 8 plus log of x cubed. And even though I am multiplying here, the 5 and the y both came from the bottom of this fraction, so it is going to be a minus, and they both are squared, so it's minus 2 log 5 minus 2 log y. Again, they both came from the denominator, so there's going to be a minus sign in front of both of them. The square is attached to 5 and the y, so the square will be attached to both of them there. And there's only one thing I can do to simplify it a little bit more, and that's this exponent here. 3 log x, 2 log 5, 2 log y. And that is expanded fully. All right, number 12 here, we have the natural log of x times. Now the fact that this is multiplication right here tells me I'm going to split them up and add them. So I'll have the natural log of x plus the natural log of the square root 1 plus x squared. But the square root of 1 plus x squared, that square root is a power, isn't it? It's a power of 1/2. That's sort of like saying that. So it's the natural log of x plus 1/2 the natural log 1 plus x squared. And that's all she wrote for that one. All right. So a quick little note, we cannot split this up. There is no law for m plus n. There's no law for adding logarithms to expand with. There's no law for that. Number 13, the natural log of 3e is the natural log of 3 plus the natural log of e. Here come the announcements.
Massey, please come to the front office. Dagon Massey, please come to the front office.
That's the natural log of 3. And the natural log of e, we all know is 1. Yay! All right. Now, this one gets pretty interesting here. So what I'm going to do before I split up the inside, I'm going to bring that 1/2 out of my log. Remember, the square root's power 1/2. So I can split this up a little bit easier. I'm going to bring that 1/2 out. So this is going to end up being 1/2, and the 1/2 is in front of everything now. So let me do it this way. Maybe this will help. I've got log base 3 of 2 plus x squared minus y squared. Log base 3 of 2 plus x squared will end up being 2 log 3x minus 2 log y. 3 log y. Where did I get that 2 from? It's 3. From here, I'm sorry. 3 log base 3 y. Okay, so again, anything I'm multiplying in the top, I'm going to add. So 2 and x squared, here's your x, here's your square, minus anything in the bottom. Here's your y, here's your cube. And then simplify a little bit, distribute your 1/2. You have 1/2 log base 3 of 2 plus 1/2 times 2 is 1, so that's log base 3 of x minus 3/2 log base 3 of y. Not too shabby, is it? All right, so number 15 says express as a single logarithm or rational number. In other words, condense. So I've got log base 2 of 48 and 1/3 log base 2 of 27. So what I'm going to do is exponents first. Log base 2 of 48 minus log base 2, and this is the cubed root of 27. And the cube root of 27 is 3. So let me set this up here. I'm subtracting those, so it's going to be log base 2 combined into 1. 48 over 3. 48 over 3 is 16. So log base 2 of 16. And this is asking 2 to what power gives you 16? 2 to what power gives you 16? And that is 4. So I'm condensing number 16 as well. 1/2, let's condense the inside first. This is going to be pretty simple. I want it down to one logarithm, so log base b. M plus n, so m and n are in the top, minus p is in the bottom. And we have a power of 1/2. Log base b, square root of m n over p. So these go pretty quick. Good little clip here. All right, couple of others. Last page. Good timing here. 17. Starting off by subtracting 2 logs. There's not any exponents to deal with in the front, so let's go ahead and subtract them. Natural log of x squared minus 4 over x plus 2. And we always want to see if we can simplify it any more. So x squared minus 4 will factor out to x plus 2, x minus 2. X plus 2, x minus 2. And so that leaves you with the natural log of x minus 2. Those go away. That's what you're left with. Over here, a lot of simplifying that needs to happen first. I've got a couple of powers here that need to go up. So log base b of x squared. This is the square root of 36, so this is minus log base b of 6, square root of 36 is 6, plus log base b of 3. So even though this looks out of order, anything with the minus is going to go in the denominator and be multiplied together. Anything with a plus is in the top. So this is log base b of x squared times 3 over 6, which is log base b of x squared over 2. So not too bad. None too shabby. Alright, last couple. Use the properties of logarithms to evaluate each expression without using a calculator. So sans calculator here. Log 5 of 1 over 25. Alright, so this is just another way to do this. You know this is looking for 5 to what power gives you 1 over 25. So you know the answer should be -2. But here's an easier way to do that. Log base 5 of 1 minus log base 5 of 25. Split them up with subtraction. This is a fraction, so split it up with subtraction. 5 to what exponent gives you 1? Well, that's 5 to the 0. Minus 5 to what exponent gives you 25? That's 2. So your exponent is 0 minus 2, which is negative 2. Or, another way to look at it, using one of the guys from the front, is as the log base 5 and change 25 to 5 to the negative 2. And then it's log base 5 of 5. You know that this will all go and leave you just with negative 2. Either way you go, simplifies to negative 2. This really helps, especially if your numbers are not so nice like 5 and 25. All right, 20. 4 log 4 6 plus 2 log 4 3. Wow. I'm going to start out and I'm going to pretend like this 4 is not here, and I'm just going to work with my exponent. So log base 4 of 6, 2 log base 4 of 3. So I've got 2 goes up here, it's 3 squared. So I'll have log base 4 of 6 plus log base 4 of 3 squared is 9. So that's going to be log base 4 of 6 times 9, 54. And 4 log base 4 goes away. 54 is your answer. So not too bad. Not a lot that goes into those, but just a lot of getting used to is mainly what it is. And it all goes back to these 5 properties here.